Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Got a kit today to build. It was from the clearance sale at JCar. It was 50% off of that, so I only paid $5.39 for this thing, and it's an old kit. It's a quick brake light trigger kit. Now, what this is supposed to do is when you let off the accelerator to go hit the brake pedal, it's supposed to light the brake lights up first before you even hit the brake pedal. So it indicates to other drivers quicker that you are about to brake. So reduce the risk of rear end collision by giving a much earlier brake lights warning to following drivers than any normal car. This project may not be suitable for manual gearboxes, and I'll get to that in just a minute. Kit includes PCB, relay and electronic components. Kit requires a throttle position sensor, or TPS, or a manifold absolute pressure sensor, MAP sensor, some mounting, connecting hardware and optional UB3 case, 10k linear pot for setup. And the reason why it's not suitable for manual gearboxes is because when you're driving a manual car, you usually let off of the accelerator before pushing the clutch in. So this will probably most likely turn the brake lights on every time you go to change gears, which is why they say this project may not be suitable for manual gearboxes. So let's get the packaging open and we will see what we've got in here. Bag of lots of components, nice electronics porn right here. The PCB, and it's actually a double-sided PCB. Nice. Okay. And of course the instructions. Now I may not be able to test this fully today because it involves breaking into the car's wiring, and yeah, I'm not really going to be doing that because my car is also a manual car, and I don't really want to start messing around with my car's wiring. But I'll see if I can simulate a bench test. Let's see, this is just preamble about, how people's driving habits and stuff. Showing of the PCB. What I'm looking for is the schematic, which is right here. So this is the schematic. So we've got star here already saying required only for the MAP sensor, so that plus 5 volt there, and the SIG, which I'm not sure why they're the same color, but it's marked with a star anyway. It goes into this buffer, which is an LMC6482AIN. Got a differentiator here with the sensitivity. That goes into this buffer here, which is the same IC. Then we go into this inverter, which is an LM358. That comes down to LH, HL, that jumper there. Comes into a Schmidt trigger, which is the LM358 second half. Classic 7555 timer. Right, quick read of the circuit detail says that this pulls the relay in and holds it on for a specific length of time and then drops it out again, so it's not like on permanently, because usually your brake light switch would take over anyway. And over here is another connector, which is for the brake pedal switches, etc., and the brake lamps. Oh, excuse me. Oh, damn. Yeah, and down here is just a regulator. It looks like a 5 volt regulator. Yeah, it's an LM2940 CT 5.0. So it gives a 5 volt rail, which is the 5 volt reference. The 7555, a wrong way diode on the input there, and this comes up with the ignition. So you would wire it off of the ignition switch on when it's on in the on position, so it's not on all the time. So the way this circuit works is this IC here monitors and buffers the signal from the throttle position sensor and feeds it to this differentiator stage, which passes high fast changing signals, and then it's fed to the Schmidt trigger over here after the inverter stage, and a rapid negative transition will occur from the throttle position transistor, i.e. during a fast throttle liftoff, causes IC2B, which is the Schmidt trigger, output to briefly go low, which then triggers the 555 timer, then enables to briefly activate the relay over here. And that's pretty much how that is supposed to work, and obviously light up the brake lights at the same time. Okay, so that's the schematic as best as I can explain it. Just having a look through here. They give you construction stuff. Yeah. They do have scope traces and stuff from various parts of the circuit. Doesn't really give you much information on installing it in the car, like pictures and stuff. It's all going to be in text. I banged the microphone, I do apologise. So I'm going to put that to the side. And I'm going to assemble this in time lapse for something to do, and then we'll see if we can actually make this do anything on the bench. So let's get building. The one thing I would do is I've got two 4.7 ohm 5 watt resistors here. I would put them high of the board, like give it a air gap of around about 4 or 5 millimeters, because those will dissipate quite a bit of heat and you don't really want to scorch the board. So let me get set up and I will start assembly. I'm going to start assembly with the low profile components such as the resistors, maybe the jumper connector here, and then I'll put the larger components in. Alright, let's get building. That's nice to see. All the ICs are in a piece of foam which has tin foil on it to help with anti-static. Plus they give you the 3 IC sockets, which is nice. I'm not sure what this kit was actually worth to start with. I think it was around about the $30–40 mark. But anyway, let's get building. Now I have to stop here at this point because I've got all the resistors installed but one. I've been given a bonus 82k resistor which doesn't go anywhere that I can see, and I'm missing a 220k. So why have I got an 82k instead of a 220? I'll need to read the instructions to see if there's any notes or errata about this particular resistor, and I'll get back to you in just one moment. Mystery solved. There it is there, marked on the schematic 82k. That must be in place of the 220k on the PCB. One thing to note, with D5 over here, they say it must be fitted with reverse polarity when lamps are on high, plus 12 volt side, i.e. ground side switching. That is if your brake pedal switches ground rather than the positive. I believe most cars are the reverse. They just switch the positive through the switch, and the lamps are grounded at the chassis end of the car at the rear. So that's just one thing to note. So, but in normal cases, it would be inserted the way it is in circuit. But you have to check the vehicle that you're going to be installing this into, whether it's ground switched or positive switched, and that's where the 82k goes. It's actually in place of the 220k, so it's next to this 4k7. Right, that was confusing. That's probably why it helps to read the instructions first. Right, this set of connectors over here have to be joined together, so these interlock with each other. So I'm going to interlock them, just like that, with the wire end sticking out that way, and that just pops in the holes in the PCB. And then we can solder it. What I'm doing is I'm soldering one pin to just get an alignment, so I can make sure they're flat with the board. And I'm using up some old solder. It came with another kit, which is great. Okay, back to the time lapse. Alright, I'm up to the final assembly step of this, which is the 5-volt regulator, this here. And they've given you a really long 10mm M3 screw, which is totally unnecessary. So I'm going to change it after I bang the mic for the 100th time to an M3 5mm long, or 6mm long, whatever they are, because it doesn't need to be that long. And I'll keep the 10mm. Okay, so as I say, you got to bend this weird, like the center lead is shorter than the outer leads. So it probably would have been easier to do this without the capacitors in. Sort of have to eyeball that. I'm going to say about yay long. And as I always say, bend your leads and put them in the circuit board first before tightening screws and soldering them. So you tighten the screw first before soldering. That's what I'm trying to say. That's about right. I mean, it doesn't have to be like perfectly straight or anything. This is not mission critical or anything. As long as you can get the legs in the board like that and the hole lines up, I can put my screw in, find the nut. See, that's all you need sticking out. It's about 3mm or so. And if I can get this started, that'd be great. There we go. So now I can tighten it. There we go. And wake the soldering iron back up. I can now solder the legs in. Thank God that this is a quick warming iron. Board could probably use a bit of clean with some alcohol. Get rid of the flux. Okay. There we go. Just trim that center lead, the other leads are fine. There we go. That's the assembly complete. So I need to install the ICs. So this is actually a TLC 555. Okay. I can't get it out of the packet, so I'll start with this one, which is the LM358. I need to invest in an IC pin length straightener. Next we can put the LM364, 648 rather. Yeah, that one goes down here. And finally the 555 timer IC. Sure that's all the way in. It's very crooked, and that socket's crooked too. Damn. I didn't quite solder that in properly. I'm just not happy with the way this IC seated, so I'm going to try and lift him out. That's a bit better. Now for the timer. There we go. All the ICs are in, and I've got to set up JP1 over here, whether it's HL or LH. So I have to quickly look at what that even is. Alright, I was just doing a quick read of the initial setup or initial testing procedure, and we'll get to the jumper in just a second. But initially what they want you to do is wind both these potentiometers all the way anti-clockwise until a faint click is heard. I think we're at 0 there. I can always measure them. It feels like the end stop. Okay, I'm just going to grab a multimeter. Yeah, I assume it's this way around. Come on. Come on. Okay, we're at 0 ohms on that one. The other one's over there. They're joined together in the middle. It's not quite 0. I can't get a good contact on this for some reason. Yeah, that's not quite 0. That one's definitely 0. So this one's not quite 0. Unless I've got a faulty pot, of course. It's highly probable. Still saying 691 mega ohm. So 690k. But then there may be something else across that potentiometer, like a resistor or something. Yeah, it goes between the output of one half of the op amp up here and the input of the other half. So I might be reading some resistance between the output and the input. So far, that's where we should be. So now I need to connect up a power supply source, and you can, according to the instructions, mimic the throttle position sensor by using a 10k linear potentiometer across this connector here. So what I have to do is I have to set up the power supply, put some fly leads and stuff in. I'll use some offcuts of resistors crap and shit, so we can see what this thing does. Right, so the first thing they want you to do is to check the 5-volt rail. Got my power supply at 12 volts hooked up. The reason we set these pots to the minimum resistance because it gives it the maximum sensitivity and maximum on time for the relay. So I turn excuse me, the power supply on. Nothing happened. So we need to measure the voltage between the plus 5 volt rail output and ground, so here and here. And we have 5 volts, excellent. If you've got nothing there, D1 could be round the wrong way. Now we can install our jumper into the HL position. Might turn the supply off for this. So that goes in that position, and the LED will briefly light up apparently. Okay, so I need to simulate the throttle position sensor on COM2 here, with the outside terminals connected to ground and plus 5 volt, and the wiper to the signal input. So basically wiring it up like a volume control. Let me draw a little diagram. So what they want you to do is, that's the plus 5 volt rail. So they want you to connect the pot like that. That's the signal output, and that's one end of the pot, and that's the other end of the pot. So that would mean we would have to wire the pot in the conventional method as you would a volume control. So there's the pot as viewed from the top. This side is ground, that side is positive, and that's our signal. So that's how I'm going to wire it to the board. Got my potentiometer wired across the connector here, set at maximum resistance as they say in the instructions, and I'm going to measure the voltage between the signal and ground point. We should see 5 volts. Turn the supply on, nothing happened. Measure between here and here, and there's our 5 volts. Okay, so far so good. So also now what we need to do is we need to quickly rotate the pot to minimum resistance. And there you go, it's actually doing what it's supposed to. However, if I slowly rotate the pot, maybe not. Okay, there we go. So initial testing is good. So what I might do is I might set up a globe on the output here so we can have a visual reference. Alright, I got it set up as if it was in a ground switch brake light with the brake switch bypassed, and C1 and C2 on this connector shorted together as the instructions. So let's do this test again. Okay, I might need to connect that to plus 12 volts. I've forgotten to connect Y connection to plus 12 volts, that's why. Okay, let me just do that. There we go. Okay, so the circuit works. So you can see why that this would probably be unsuitable for a manual car, because as you're letting off the accelerator, the brake light will flick on for momentarily and flick back off again whilst you change gears. So that is probably not appropriate. But anyway, the initial testing of the circuit has passed, so then we can now rotate VR2 clockwise to set more on time for the relay. I got VR2 and VR1 mixed up when I was saying why we set them to counterclockwise. Setting this one, VR2 to counterclockwise, sets the minimum on time for the relay. So now we can increase our potentiometer clockwise to make the relay stay on longer. So that's a bit longer. You only need it to be on long enough for it, you lift the foot off of the accelerator and hit the brake pedal. So that's pretty slow now. Nice. VR1 is sensitivity. So we can probably make it less sensitive by rotating the potentiometer VR1, because if I do a slow turn of the pot, it's reacting. So we want to reduce the sensitivity. That did nothing. May take a bit of resistance to, because you don't want this coming on when you're just slowly letting off the gas. That's a bit better, but it's still a little bit sensitive. Yeah, it's still sensitive. By the way, this kit was bought at JCar during their 50% off sale, which started on Thursday and ends today. And this kit was sitting there, so I thought, well, it looks interesting. Won't be able to actually use it. It's still sometimes triggering, and sometimes not. That's probably about right there. So let me do a quick turn down. So that's as if the accelerator pedal's just been lifted up off of. Shouldn't really matter what position you're in either. There we go. That's all you need it to do. Give it a little bit more on time. Maybe a bit more. Excellent. Well, that's pretty much all I can do with this particular kit. I just mainly presented it because I found it interesting. So it does what it says on the box. So I'm happy. Now, if you enjoyed this video, please go down below, like, comment, and subscribe if you haven't done so already. And as always, this is the Astro 30 saying thank you for watching. I'll see you in the next one. Cheers, bye. Oh! I don't know what that was.